In this video, we'll look at the basics of functions. In Java, they're also known as methods. In this video, we're going to look at void functions, and we'll start with a simple program here, functions 1, with a main that has two output statements. And let's see how that. Okay, so just a introductory message and then a concluding message. The idea of a function is to separate some meaningful component of code and give it a name such that it enhances the readability of the program and the size and reliability of it. All right, so for example, suppose I have a message that I want to print. I can effectively just make up a command, make up a new called print my message. And then introduce another component outside of main that will respond to this command. So this statement here now is known as a call statement. And it has to match with a definition within the same class. So we have the public class functions 1. And then within that, we've been writing everything inside these braces here, but now we can introduce components that are separate from main that we make up. So I'm going to now create space between the closing brace of main and the closing brace of the class, and we're going to provide a definition for what is supposed to happen when this executes. So it has to start off like this because the call statement is in a static function. This also has to be static. And then void is the next thing we want there. Sometimes that'll be something else. For right now, it's void. For this one, it's void. And then we repeat the name of the function and then provide a parameter list, which in this case is empty. And there will always be a set of parentheses after the call and after the definition. They'll have different things in them sometimes, but that's how the system recognizes that it's a function call and not a variable. All right, so this is a header, just like this is a header. It's a function header. Following the header, we have a set of braces. This is a compile point of itself when the function is void. So for a void function, reach a compile point, you want to see it's going well. And if there's no news, that's good news, and you can proceed. All right, so the well-defined task that we want this message, this function to execute is to display this message. So and we'll recompile and execute that. And now we see, and notice where the message, where the output falls in the terminal, right? The opening message demonstrating functions. Then the call statement sends execution control to our new definition down here, and execution continues from here. So that's where we see these two output statements. When we reach the closing brace of this new function, that's it. That's all that was it was supposed to do. So control picks up after the call, and then we see by. And when main ends, that's end of the whole program. So that's it. Right, so we don't go back and do this again, even though this is under main. Right? It happened when there was because there was a call statement in between the opening and closing messages. So notice I comment out the call statement. It doesn't happen. So important to understand with functions, right? Just writing them and having them in the file isn't enough. It has to be accompanied by a call statement for the function to execute. So a little bit more interesting example, we'll see we can capture all the sub-steps needed for some small task. For example, suppose we have something I want to capture the behavior to add two vowels. This is a call statement. And notice that just having the call statement actually breaks the compile. Observe. Right, so we get error cannot find symbol, add two vowels, this call statement, right, on line 10. Right, there's line 10. It's because I'm trying to send control to a different place in the class, and it doesn't exist yet. I haven't defined it yet. All right, so we can define that. And notice these don't have to be in the same order that they're called, right? I'm going to put the definition for this call statement ahead of the definition for this one, and that's perfectly fine. All right, the system sorts it out and executes them in the order of the call statements, not in the order they're presented in the file. So I'm going to start this out static, void, add two values, and then once I have braces for a void function, that is enough to compile. All right. And you could run it, nothing's going to happen, all right, except this one. All right, so to add two values, all right, is actually three different steps. Right? I have to have input, then I'm going to calculate something, then I'm going to show the result. So for input, right, I'll start with a prompt. Right, and now I need an input statement, right, to actually capture the two values, input val, and let's say terminal dot next int there, and likewise for a val 2. All right, so there's the input, except I haven't defined a terminal yet. Right, I don't have one. And maybe your first instinct is to put it right here and say, okay, well, I need a scanner called terminal in. Okay, and that's fine. Right, you can put it there. However, once you start using methods, it's common that some methods may want to share, right, the same object. That's certainly true for a keyboard scanner, right, an input scanner. And it's often more convenient to place this in the class scope, right, and then to make it visible to everything, we say it's static. Right. And this makes the scanner object visible and usable to all functions. Right? Then you don't have to declare it in every single function where you use it. So something like that, And now we'll get two values. Right, this will stop and ask for two values. Doesn't do anything with them. Right, so we have to finish. We have two more steps to finish. And our two values, 4, 6. 4 plus 6 is 10. All right, so that is another way you can use a function, right, to capture just all the substeps that we need for an entire problem, with the possibility of sharing, sharing certain things among all the functions. Right. Another way we can do this, though, is to separate things, and this often lets us write more flexible functions. Right. So in the next video, we'll see how that works.